Hello everybody, welcome to our video. Well, you thought that this lesson would be a little bit harder since we had a rock, paper, scissors. I still hate you, Emily Smith. Just kidding. But you have to find, this is finding the area using a sine function and Herons formula. Now, we all know back in elementary school and middle school we learned the area of a triangle, which is A equals 1/2 base times height. That's the very simple one where we have a height. Let me draw a height with our handy dandy Spider-Man ruler. We all know that this right angle here would be our height, and we can use C as our base. So A would equal 1/2 C times H. Well, what if we're not given the height, but we're given side B, angle theta, and side C? And that's where we can use a sine function. Now, when I drew this line, you guys can see that it forms a right angle. And with that, we can use a sine function in order to find this height, and we can plug it back into this equation. It's really simple. So, if we can do sine of theta equals, then we need to do opposite over hypotenuse. So B is our hypotenuse, H over B. You solve for H, so H would equal sine theta multiplied by B. And then from that, we can get this height, and we can plug it back into the regular area of a triangle equation. And then finally, should A equals 1/2 times B times C times sine theta. And that's really it. This is the equation right here. If you guys want to record that down, you can. But it's as simple as that. However, you can only use this finding the area of a triangle using sine function only if it's an SAS triangle. What does that mean? That means that the triangle must have a side, an included angle between the two sides, and obviously the other side. So I can only use B, this angle, and C. If they're given us B, this angle, and A, we wouldn't be able to do that. We needed an include angle. An include angle would be the angle between the two sides. So basically, the included angle between B and A would be this angle, which would be just angle capital C. Then for this one, we can opposite of A, so this will be angle A. This will be angle B, capital B. So you can see that it has to be included. So it has to be C angle B A, or B angle A C, or B angle C A. So I'm going to fill in the rest of them using all that. So area would equal, we're going to start off with angle, they give us side C, angle B, and side A. So 1/2 times C times A times sine of B. It's really all it is. And then you do the other side for side B, angle C, and side A. So area equals 1/2 times B times A times sine of angle C. Very simple. So I'm going to do an example right here, which will be fairly simple. We can have our base as 6. We can have our side B, or this regular side right here, as 8, and our angle can be 30 degrees. Also, if you guys want to pause the video in order to copy these formulas down, you also can do that. Alrighty, so in order to make it visualize again from up here, we can draw the height if you want to see it out. If not, you can just plug in everything into the equation. Doesn't really matter, but it's better for you guys to see where the sine is coming from. So sine of 30, which we used from our unit circle trig, should be 1/2, but we can check with a calculator. So sine of 30, all that, sine of 30 is 0.5. Sine of 30 equals H, we'll call this H over 8 sine of 30, so 1/2 times 8 equals h. 8 divided by 2 equals 4. So our height would be 4 here. So we can plug that back into the triangular equation, or one of these equations up here. We have a equals 1/2 times our base, which is 6, times 4, which is our height. And we can get out to be 6 times 4, 24, divided by 2, 12. A equals 12 centimeters cubed. We'll call these centimeters right here. Very simple. We're going to do some more practice problems to just figure that out. If you guys want to take some time to copy that down, pause the video. Alrighty. So what we have here is we have a triangle that has a side 8 centimeters, an included angle that is 87 degrees, and a side that has 6 centimeters. So if you really want to visualize it again, I'll do it one more time. That this side right here, I'll flip it like this, will have a height. It's going to be a really small leg if we're going to try to do perpendicular, since it's going to be like an 87-degree incline. If you guys can see that, it's really small. However, 8 is still going to be a hypotenuse in that. So what we do is we plug it back into the equation that we had, which is area equals sine theta times side, or b, times c, and then times the 1/2 that we had before. Just wrote it a little weird, but area equals sine of 87 times 8 times 6 divided by 2. So we can plug that in your calculator. Sine of 87 multiplied by 8 times 6 divided by 2. And we should get an area of 23.97 centimeters cubed. Not cubed, squared. So there's an example right there. It's kind of very similar to the last one, except for it's just a very difficult angle. So when we go to the next one, what do you do if there's an obtuse triangle? So whether you do the sine of 140 or do a sine of an acute angle, well, it really doesn't matter. Because if we go back from our unit circle trig that we had before, this would, if the unit circle, on the unit circle trig, if this was 40 degrees, and make it all the way around, this would be 90 degrees. Then you add another 50 to go to 140. And this is 180 degrees. This is 90 degrees. And this right here, total, would be 140 degrees. We have all that. 180 minus 140 is 140, is 40 degrees. So, sorry about that. So, the sine is going to be exactly the same for right here. They will have the same sign. Obviously the cosine will be negative, but they will have the same magnitude, but they will have the same sign. You can go ahead and check that in your calculator as well. Sine of 140 equals 0.6427, and sine of 40 is 0.6427, the same exact number. That's why it doesn't really matter if you really want to use it. And if you want to see it, we can flip this triangle over right here, where this would be your height. 6 inches right here, if you want to look around like this, 6 inches right here would be our hypotenuse. 180, if you use our complementary angle here, 180 minus 140, this would be a 40-degree angle here. And the sine of 140 times 6 will get us our height here. It's very simple. So if you want to plug it into here, sine of 140 times 6 multiplied by 5 divided by 2. So we can plug it into here. Sine of 140 times 6 times 5 divided by 2. This should give us an area of 9.6 inches squared. And you can do the same thing with the sine 40 if you really wanted to. So area would equal sine 40 multiplied by 6 multiplied by 5, sorry about that, divided by 2. Now when we divide that by 2, the area should come out to 9.6 again. If we do sine 40 times 6 times 5 divided by 2, and it goes out to 9.6 inches squared. So that's it for finding the area of a triangle using a sine function. Now we'll be going to finding the area using Herons formula. Herons formula. So, Herons formula is actually not that complicated as it sounds, or as it looks right now. So this guy, this Greek guy named Heron, or Hero of Alexandria, I believe his name was, he made this huge equation based on the Pythagorean theorem and the area of a triangle, and got this formula right here, where S would be plugged into that. That theorem and how he worked that out is really long and tedious, but if you guys want to go see it and how it was worked out, it is in the textbook in section 5.6. It's on there, and it's really long. It takes a whole page up, and if you guys are willing to look at that, you can, but I think it's easier just to memorize this, and honestly it's really easy if you have all three sides. Now, since the last triangle that we had, it was only used for an SAS triangle, meaning side, an included angle, and a side. Herons formula is for using an SSS triangle. So you can only use Herons formula when you're given A, B, and side C. So you have to be given all three sides in order to use this formula. So if you look right here, this S equals A plus B plus C divided by 2. So it's the addition, the perimeter of the whole entire triangle divided by 2. So, and when you use that, you can just use S, plug, and have your own written out S equals that, and you plug everything back into this formula and plug it right into your calculator. It's really simple. So we can do some example problems off that. So we have right here a triangle that has a side of 7.5 inches, a triangle that has an 8 inches, and the side where it has 14 inches. So what we're going to do, we're going to try to solve for S. S would equal 7.5 plus 14 plus 8. Make that. I'll write that out real quick. Plus 8 divided by 2. S would equal 29.5 divided by 2. Actually, I'm sorry about that. 14.75. So S would equal 14.75. Alright. So now that we have S, now we can just plug it back into the equation that we have here. So area would equal square root of S, which is what we have is 14.75, and then you guys look, I'm getting it from right here. So 14.75 times, sorry about that, hold on, 14.75 minus A, and we can we'll label this A, B, and C if we really wanted to. So we have A right here, 14 minus, sorry, my left hand's covering it up. It's 14 minus 7.5, and then 14.75 minus 8. You guys can see that. Let me finish this off. You guys see that right there? And then multiplied by 14.75 minus 14. So we just plug that on our calculator, and we have 14.75 times 14.75 minus 7.5 times 14.75 minus 8 times 14.75 minus 14. There we go. Should give us that, and we just square root of that. And there you go. The area should come out to be 23.27 inches squared. So if you guys want to see through my calculator what I did there, sorry for TI-84, but that's just the way it is, how we have to type it in like that. Then once I got that answer, I square rooted that, just like in the equation, and I got my area. We're going to do another triangle to show you how you guys do it. It's fairly simple again. We try to find our S equals A plus B plus C divided by 2. Okay, so we'll make this A, we'll make this B, and we'll make this C. So A and B are 14 and C is 13. So we make our S equals 14 plus 14 plus 13 divided by 2. Plug that in my calculator. 14 plus 14 plus 13 divided by 2. S equals 20.5. So now we can plug S equals 20.5 back into this equation right here that we had before, just like that. So A equals square root of 20.5 minus 20.5 minus 14, 20.5 minus 14 again, 20.5 minus 13. You guys want to look at that? Close the parenthesis here. So that's what I have right there. So I'm going to plug that in my calculator. Square root of 20.5 times 20.5 minus 14 times 20.5 minus 14 times 20.5 minus 13, and close that parenthesis. Should give us an area of 80, sorry about that, 80.59 or 80.6 if we round it, 80.6 centimeters squared. So that's basically it for Heron's law. It's fairly simple, simpler I'd see, fairly simpler than law of cosines or sines. So I think I chose the right topic for the rock paper scissors shoot. Thank you guys so much for watching, and we'll be passing out worksheets for you guys, and we'll be helping you. There's gonna be different problems on those worksheets, and thank you guys.